So my name is Carsten Degenhardt. I'm the work package leader of work package 5. The core task of that work package is to develop electronics that can control and read out the qubits. One of the main challenges is that one task of QSolid is to reach very high fidelities with the qubits. That means that we have to be able to develop electronics that can very precisely control the qubits. And we have two routes there. The first route is that we have room temperature electronics, and the signals are then fed into the cryostat where the qubits are cooled to do the operations on the qubits. You can do that to maybe a couple of hundred qubits, but when you think of scaling it to thousands, 10,000s or even million qubits in the future, it will not be possible to feed in all these lines into the qubit, into the cryostat. So in order to circumvent that problem, in the second part of the work package, we are working on cryogenic electronics that operates with the qubits that can be placed into the cryostat. So you don't have the wiring coming out from room temperature into the cryostat, but you can directly connect the electronics to the qubits. The challenge there is that the electronics that are available today are not really made to operate at these low temperatures. So we are characterizing these electronics at these temperatures to be able to generate electronics that will work at those temperatures. And we also take care that the heat that is generated by the electronics does not heat up the qubits, since then the qubits would not work anymore. So those are the two main challenges we are addressing in that work package. Yeah, the first step is always that you agree on requirement specification, that you really know what do you need and that you can also verify your electronics later on against these requirements. We have done that in the team. We have also developed the complete concept of the electronics. So the next step now will be to implement the electronics and then verify against the requirements.